Now that we've seen how to do separation of variables, how to solve a differential equation using that method, let's now go and take a look at not just a differential equation but an initial value problem. So here we have the initial value problem consisting of our differential equation dy dt plus 0.5y equals 0 and the initial condition y of 0 equals 7.3. And let's remember this means y equals 7.3 when the independent variable, which is t in this case, when t equals 0. So you'll recall we already solved this differential equation by separation of variables. Our solution, so the solution to the ODE was y equals c e to the minus 0.5 t. And now what we want to do is apply this condition over here, y equals 7.3 when t equals 0. So we just put 7.3 in for y, and we put 0 in for t. So we have c e to the minus 0.5 times 0. So this is e to the 0, which is 1, which means our constant then is just 7.3. Now we don't want to always assume that the constant will be this value given to us, the initial value, but in this case it turns out to be. So the final solution to the initial value problem is y equals 7.3 e to the minus 0.5 t. It's our solution to the differential equation with the value we determined for the constant inserted. Now let's look at another initial value problem which uses the other equation we solved by separation of variables. You may want to go back. Let's see, our solution to this guy, to the differential equation, was 1/2 y squared equals 1/3 sine 3x plus c. So why don't you pause the video for a moment and go ahead and solve the initial value problem. Use this initial value problem to determine c and see what your final solution is. So go ahead and pause now and we'll pick up here in a moment. Okay, so coming back, what we want to do is remember this means y equals 4 when the independent variable, which in this case is x, when x equals 0. So we put in a 4 for y, we have 1/2. 4 squared is going to be 16, of course. And we have 1/3 times the sine of 0. And we put 0 in for x, 3 times 0 will be 0, plus c. And so in this case, the sine of 0 is 0. And so c equals half of 16, or 8. So our final solution is 1/2 y squared equals 1/3 sine 3x plus 8. And so that concludes showing how to solve some initial value problems by using separation of variables for the differential equation.